We will now verify whether mean value theorem can be applied to this function f of x equals x power 4 minus 8x defined in the closed interval 0, 2. So according to the mean value theorem, f of x must be continuous on the closed interval a, b. F of x must be differentiable on the open interval a, b. Then in that case there exists a c such that f prime of c, that is the derivative of the function at c, equals f of b minus f of a over b minus a. So let's verify that. So we will first check whether this function is continuous and differentiable. Notice that x power 4 minus 8x is a polynomial function, and from polynomial functions we know that it is continuous as well as differentiable on its domain. So the first two conditions of the mean value theorem are satisfied. That is, this function is continuous as well as differentiable, which means it must satisfy this condition, that is f prime of c equals f of b minus f of a over b minus a. So first I'm going to find the derivative of f of x so that we can find f prime of c. So let me find the derivative, that is f prime of x. This equals, you have to find the derivative of x power 4 minus 8x. Derivative of x power 4 using the power rule is 4x cube, and derivative of negative 8x is 8. Because the derivative of x is just 1, so it becomes 4x cube minus 8. Now we can find the f prime of c. We just have to replace x by c into this equation, and when you do that we get f prime of c. This equals 4c cube minus of 8. So we found the left side expression, that is f prime of c. Now we will find the right side expression and we will replace this equation. So I'm going to write down f prime of c, which equals 4c cube minus 8. This equals f of b. Here a is 0 and b is 2. So this becomes f of 2 minus of f of a, which is 0 here, over b minus a, which is 2 minus 0. Now let's find out f of 2. We can replace x by 2 into this equation, and when you do that we get f of 2 equals 2 power 4 minus of 8 times of 2, and this equals 2 power 4 is 16 minus 8 times of 2 is also 16, so this becomes 0. So basically f of 2 is 0. Now let's find f of 0, and this equals 0 power 4 minus of 8 times of 0, and this is once again 0. So we see that f of 2 is 0 and f of 0 is also 0. We will replace it over here. So therefore this becomes 0 minus 0 divided by 2 minus 0 is 2, and so this becomes 0 over 2, and this is equal to 0. So therefore we have this equation 4c cube minus 8 equals 0. We write down 4c cube minus 8 equals 0, and from this we can determine the value of c. So let me add 8 on both sides, then I will get 4c cube equals 8. Then I divide both sides by 4, then it becomes 8 by 4 is 2. So from this we can determine c, which is the cube root of 2. So c equals cube root of 2, and this is approximately equivalent to 1.2599. So we see that mean value theorem is applied to this function, and we have also determined the value of c as 1.2599. Clearly this value of c lies in the interval 0, 2. So this is the value of c. In part B we have the function f of x equals cos x plus tan x defined in the closed interval 0, pi. So let's verify if mean value theorem can be applied to this function. This cos x is continuous everywhere. However, this tan x function is undefined at x equals pi by 2. So we see that the sum of the functions, which is trigonometric functions, it is undefined at x equal to pi by 2. And this means f of x is not continuous. See, it is not continuous at x equals pi by 2. So this clearly indicates that mean value theorem, which is shortly written as MVT, this cannot be applied to this function.